What I'll be talking today is that, how we can scale NFV. Maybe I hope it's not too late to do that. Originally was how to scale, then I said how to Mega-Scale, and then I said let me, upgrade that to ultra scale. So Orange, we're like a global operator. We work operations around the world. I'm going to skip that. So this is from Dilbert, and he's asked how to build a large NFV system. The bad news is we don't know how to build a large NFV system, and at the end of the day, it's virtual, right? How hard is that going to be? So let me jump into that. So we know that in terms of like legacy VNFs, which is like sort of like the old-fashioned or traditional VNFs, that's what we started seeing like 6 years ago or 5 years ago, is that it's simply like they would take like a software version of the hardware and they say, hey, here's your solution, if you're looking for a VNF. So it would be the equivalent of the physical appliance. And obviously this is quite monolithic, right? There's less flexibility if you want to scale up. It required many resources. When we're like working with VNFs early on, they would require us to like allocate a whole server for that. And that's really an expensive proposition, right? And it wasn't really optimized for cloud operations, and cloud was coming up. There's absence of APIs and mostly important, open APIs. And it was very, very vendor, of course, oriented. And as I said, not easy to scale up and out. And it would simply fit the classic way of architecting networks. All right, so I'm sort of like introducing the concept of the micro VNF, right? And I know that you guys think about microservices, and we'll discuss later on, how that fits into the microservices. So essentially, we're looking here at a very scaled down, very lightweight version of a regular VNF. And that can be a very small piece of code that you can run, and it can run on a small and compact factor. If it's hardware, it's going to be, it could be anything. It could be a Raspberry Pi. It could be a system on a chip, working in a multi-core environment. It could be even your smart mobile device, right, whether it's a tablet or an IoT device, etc. In terms of software, it has to be running on a container, and Linux are always very friendly environments to run this type of software. And again, this is going to be based on a very completely modular, decentralized architecture, where you essentially deconstruct and functionally decompose these monolithic VNFs that appeared early on. And they're much, much smaller. They are atomic and autonomic. And so if this is your classical VNF, it's going to be transformed to something like that, perhaps. So what you need, you see there's like gaps between these micro VNFs. So all you need there is the API. So the APIs will provide the glue between those micro VNFs. So this is a very modular architecture. And the nice thing about it is that you can swap in and out other VNFs, other micro VNFs that you want on a sort of like on a demand basis. So in terms of properties, these micro VNFs will have to execute a very specific task. It could be just a single one, that they have to execute. They're transient in nature, which means that maybe they can last only a few minutes or a few seconds or a few hours. You decide what's going to be. They can obviously scale dynamically and independently from other micro VNFs that you might be running at the same time. They don't have to be collocated. And I think, in my mind, this might be important if you can get the gist of it. They don't have to be running on the same environment, so they can be like spread even physically across maybe even different geographies. I don't know. They have to be going to be easily swappable and reusable, so you can reuse the same VNFs if you want micro VNFs, and replicable, so you'll be able to replicate on a demand basis. In my view, I don't think this is something that you want to share the same micro VNF amongst different service chains, just to preserve the independence. They're going to be seamless and stateless execution. And the one thing about these micro VNFs is like sort of like live organisms, if you like, that can sort of like mutate and they can morph as they're being deployed and executed, depending on the current conditions of the network. And regular VNF can be broken into these micro VNFs and it will be up to the designer actually to decide how these are going to be broken down into these micro VNFs, right? There doesn't be one particular pattern that you have to follow every time. So again, whatever the designer or the architect likes. It has customization is going to be very, very important. So you can customize these micro VNFs according to your application, to the user profile, to the device. You choose, what kind of that pattern or profile it's going to be. And then obviously, you're looking at with the vast number of the enormity of the micro VNFs are going to have is that you have to apply some fine-grained computation and parallelism. And this one shows like the difference between containers and VMs. So obviously we might prefer to use containers for these micro VNFs. So how do I, use these micro VNFs to ultra scale? So here I'm looking at a very dynamic type of chaining for these micro VNFs, so you can compose and decompose constantly. These micro VNFs are going to be coupled only during runtime, so you don't have to sort of like predefine that ahead of time. So they have to do that during execution time. And you're going to do per service instantiation. So this is very, I'm looking for something which is very, very customizable. So, the definition here of a VNF is expanded to include other functions, and I'm trying to sort of like answer Mark's. I have the same question as Mark before. Okay, what are going to be these, new VNFs, right? So, so it can include, functions as policy control. We're looking at quality of service, traffic engineering, traffic offloading, analytics, of course. You can start thinking of these as VNFs if you like. And again, it's all about building this customizable environment and in terms of personalized applications and services, which I start calling like this the Legolarization, I don't know how you pronounce that, of NFV, right? Interlocked building blocks that you put together to make these very dynamic service chains. So for instance, like a mobile app that is running on your mobile device, it could be part of of this microservice chain, and again, it can change from time to time. So a micro VNF-enabled element essentially becomes a programmable device. You can push down policies on demand, and so forth. For the scalability, again, the important thing to remember is that you need to scale only those micro VNFs that need to be scaled, so you don't have to replicate the entire system. That's very, very important, and somehow, of course, the redundancy becomes easier and more efficient since you don't have to think about, replicate the entire system, but only those critical components in order to make your system, highly available. So in terms of requirements for that, now if you have this, vast enormity of micro VNFs, so you have to think, okay, how am I supposed to orchestrate this? And that's going to be a real challenge, right? If you have like tens of hundreds or thousands of these micro VNFs, how I'm going to like orchestrate these. And so it maybe, could be different architecture that might, be appropriate here. And the second thing is that, of course, given the large number of micro VNFs, of course, you have to do some automation, and people, spoke about that. So it's all about, on-demand instantiation, auto-scale elastically, self-monitoring, self-healing, self-learning. There's some of the AI concepts getting into that, auto-recovery, and of course, the zero-touch provisioning and deployment. And I just, took a photo of this. This is in the bathroom. So it says, like, another word for zero-touch is touchless. It just says, like, so if you want to flash, just wave your hand. Anyway, so and a nice example that we saw early on in this journey of NFV back in 2013, 2014 was VPC. VPC is a really great example of how you can actually decompose an entire architecture or entire system into many, many pieces. And this is very applicable because us being a mobile operator, if I see a spike in a particular area, it could be a stadium, it could be some event, same thing as for CDN, right? Then I may want to apply more resources. I may want to deploy resources. I don't need to essentially replicate the entire system, just the functional blocks that need to be scaled. So that was a really great example, and then they call that the node disaggregation, essentially. And other examples are like the virtual IMS, SD1 and VCP, microprobes. We're working on early on with some telemetry applications. So you can think these microprobes, they flow around the network to collect, certain data and statistics. So you can think of this like, good viruses that spread around your network. Okay, so micro VNFs for the mobile. I'm always very keen on working on these type of applications because I think mobility is really a great example. And if you want to start deploying these micro VNFs at the mobile edge, because you're going to have certain restrictions with respect to your footprint is typically a much constrained environment. And these micro VNFs can perform different functions from security to DPI, deep packet inspection, filtering, and so forth. And this has been my vision all along, that maybe one day we can start deploying these micro VNFs on the mobile device itself. So if you're a manufacturer, you might be interested in these as well. Again, same things of applications there, quality of service filtering, load balancing on your mobile device itself. And then the next thing is VNF roaming. One of the use cases early on NFV was the network functions visualized infrastructure as a service. And the idea there is that if you have two different environments that belong to different operators, service providers, is that how can enable sort of like roaming. If I want to use some like VNFs on somebody else's network, how should I be able to do that? And that's it's been kind of how it fits in. And other things that again you can break down, you're looking at VPC, as I mentioned before, and VRAM functions. And I think if you start, there's a lot of discussion about edge computing and whether it's mobile edge computing or not, or multi-axis, whatever you call it. I think the concept of micro VNF fits perfectly. And if you want to run, especially somebody mentioned the other day, if they want to run that on a light post, I don't think we're going to be running edge computing on a light post, but if you find a great application, why not? For IoT, I think it's a perfect fit as well. Especially for the end devices. It could be a thermostat, it could be anything, especially when security is involved in these things. Again, NFV orchestration is very important, especially when you're dealing with heterogeneous IoT elements. And so if you're looking, for instance, a good example is that if you're looking at an IoT network, you can have a slice assigned to that IoT network, and you can have like a cloned version of the VPC that actually in the VRAM that handles that particular slice. And it's all about, yes, of course, automation, the orchestration, and the IoT services running on this. Just showcase, this is your edge compute node. Obviously, 5G very, very important. In this paradigm, and then this is your, obviously, transport network, and this is your back end, essentially. So this thing will be running here, essentially, right? The micro VNFs at the edge node, and also at the base station at the access side. MVNFs and machine learning and AI. So you can start deploying these micro VNFs throughout your network and they can also perform certain machine learning tasks, if you like. As I said, I view these micro VNFs as like live organisms, again, that they, that they learn, they crawl around your network and so forth. They collect data and information. And can have a neural network of these micro VNFs. So that might be particularly important for security if you're doing forensics and so forth. Edge computing, as I mentioned before. And again, if you want to do some sort of like optimization in the mobile space. Again, orchestrating and synchronizing these micro VNFs is going to be definitely a challenge. So you can apply different techniques. You can start thinking about like, parallel and distributed process and so forth. And then you can, whatever you learn, you can sort of like apply to your network. Microservices, you know about that. I'm not going to cover too much about it. Again, these are like lightweight and autonomous modular software components. The key thing to remember here is that micro VNF does not necessarily mean microservices. So you can run, independently micro VNFs from the microservices. Now, in a typical environment, of course, these things, fit together, and because they both are, dealing with the kind of like breaking down a monolithic architecture. And so obviously they do go together, but as I said, they can be still independent. Again, the idea here is to build these customized and personalized services. So I'm looking here for dynamic VNFs for, again, specific purpose and time. They could be, easily to set up and tear down, auto provisioning. Can be based on various criteria, whatever you decide that to be. And Kubernetes, of course, is in my mind, it's a great environment for implementing this type of microservices and micro-orchestration. That brings me to VNF as a service, virtual network functions as a service. Some of the granular computing principles could apply here because you're dealing with a very large number of these tiny VNFs, essentially. And you're trying to mimic a large-scale parallel processing type of environment. Throughputs, you need high throughput, of course. And I mean, in terms of requirements, you need high throughput and which means low latency in most cases. And the other important thing to throw here is the serverless computing. I mean, this is coming up a lot in many discussions, so you can think that, that fits pretty well with this environment. Okay, no provisioning management of the server, so you don't need explicit, reserve servers and virtual machines. It happens automatically. Again, there are really, really good examples out there in terms of providers here. All the traditional cloud providers do that. Again, it's all about building and these customizable VNFs on the microservices to offer this as a service. All right, and that brings me also to the concept of the native VNF, which is the exact opposite of the legacy VNFs. And some people call these cloud native VNFs, but it doesn't have to run on the cloud itself. So VNFs can be packaged as a virtual appliance or cloud-based, as you know. But moving away from the classical model, you can start thinking about how you can actually build and rethink how to and redesign these VNFs essentially from the ground up. If your environment is completely a cloud environment, whether it's the edge cloud or the cloud itself, and typically have to be hardware agnostic, API driven, and so forth. Again, stateless and on-demand deployment. Same principles apply here, more automation and so forth. So when you start thinking about these new VNFs, right? I mean. We think that the whole idea about NFV was to see how we can spur further innovation, and you can start using your imagination what these new VNFs are going to be. They have to be sort of like application tailored, if you like, but with some sort of like intent-driven orchestration. And great examples or use case might be VR and AR. It's up to you guys to start thinking about how you can build these. IoT connected car. You look at blockchain and cryptocurrencies and all of that stuff, digital payments, and autonomous devices, robots, and drones. These are very good areas to start thinking. I think 5G can change a lot of things, and I'm hopeful that it can enable this new slew of VNFs. Okay. All right. So this is something that I presented before, like an app store for VNFs. The only thing I noted here is that this is something that can be, sort of like intent-driven, but you can choose whatever VNFs you want, and then, you can put them together. You can choose your orchestration, and then you just simply, go and check out. And again, serverless computing can be a great environment to implement something like that. And let me see, okay, about the SDN, and this is like sort of like associated with DevOps, and then you have NFV, which is about the new kind of business models, and also the open innovation. This is something that we present in the white paper on NFV early on, how these things, go together. So open innovation is going to be all about DevOps, essentially. All right. And the APIs, of course, and the microservice in between. And that brings me to the micro-codification of the network, if you like. Again, I think in terms of how I can use these micro VNFs, for essentially providing cloud services. I'd like to see also some benefits for the user. So you can start thinking of like this personal cloud, something like building your own type of services that you like, that you can access from anywhere you want. A very customizable experience. It can be your car, it can be your home, it can be your office, it can be anything. And well, if you thought that micro VNFs is the solution to these problems, I don't think so. All right, so so you have to be ready for the nano VNFs and nano services. And I don't know whether you can recognize this, but this is sort of like a smart pill. So one day I sort of like envision that you can run these micro VNFs even on a smart pill that you can ingest. And so like my last slide here. This is a picture from the Computer History Museum before they renovated. And if you go, that's the last section. It used to be the last section in the Computer History Museum. It was about software. And as you see, there's nothing there, right? I mean, the previous sections, have hardware. And this is the, after they renovate the Computer History Museum in Mountain View. It talks about, software and how the software can change, essentially, the world. All right, so I had to rush through that because somehow we got delayed a lot today. That's about it, I guess. Are there any questions? Yes. I'm probably going to take one question, right?
Just one question, because we have the slip the time. Yeah.
And you're going to get the slides, so don't worry if you didn't have time to take photos or
sure.
Please go ahead.
Do you see these micro VNFs to follow the Etsy element manager orchestration, all this heavy orchestration, or they will have a different paradigm of orchestration?
Yeah, so that's a good question, right? So you have to think whether current efforts around orchestration might are these scalable, right? If you have like hundreds or thousands of VNF, I don't have the answer to that. When people design things, they have to take scalability into account. Okay, you don't want to design something that's going to be good only for a certain amount of elements or functions in this particular case. So I don't have the answer. So if you ask me, the way to deal with that would be kind of like a cluster approach or hierarchical approach. You have a master orchestration. And then you have, sort of like small orchestrations that, deal with certain functions. But ideally, as I said, that's going to be a challenge, and we might see that happening even with regular VNFs, right? And how you can scale the orchestration. So maybe some of the, AI stuff. I don't know whether that's going to help at all, or the automation. I don't have the answer to be honest. But this is not something. Orchestration is a topic or a subject I don't really touch at all. That's why it's called zero touch, right?
Thank you.
All right.
Thank you,
guys.
Yeah.